Good day, guys. I hope you're all doing so well. So today, that's the exponential graphs, ne? Yes. So guys, don't forget to subscribe, like, and share. So as we're preparing for June examination, so we're gonna upload each and every day for the next 5 days, ne? So ongasabi, we are still here, guys. We are still here for mathematics, paper 1, even paper 2, and plus physical sciences, ne? We are here, guys. So the basic function or the basic equation or the general equation, let me just start with the basic equation of exponential functions, guys. Yes, we've got, or it is y equal a to power x. So some people some people they think ukuthi hyperbola or the shape of the shape of the graph or the way the graph it is thrown of exponential, it is similar to that one of a hyperbola, guys. The hyperbola graph has got reflection all the time. Exponential graph is only one graph, not two. There's no reflection in the exponential function, but there is a reflection graph of hyperbola. But this one is only one graph. There's no reflection for it unless it's a inverse, which usually come to a part at the latter stage. So the basic function for exponential graph is y equal a to power x. Then obviously the value of a, it determines the shape of the graph. It determines the shape of the graph. If the graph is positive, then the value of a will tell you is it increasing or decreasing. Basically, that's the value of a, that's the functional value of a. So you know any number to power 0 is 1. Even a to power 0 is equal to 1. For us to see or to recognize or to realize that the value of a, it is positive or it is increasing, the value of a has to be bigger than 1, meaning that our graph will look like this when the value of a, it is bigger than 1. This is how our graph will look like. Perhaps let me just draw the Cartesian plane so that you can see it properly. Yes, guys. Supposedly we have some sort of a graph like this one. This is how the function of exponential will look like. Then the coordinate here are going to be 0 and 1, because when I want intercept, when I let x be 0, then I need y. The value of y is going to be 1 and the value of x is going to be 0. That means the coordinates for this point is 0 and 1. Hence the graph, it looks like this. I hope guys understand. Then basically this graph is increasing when the value of a, it is bigger than 1. Then how will our graph look like if the function or the graph is decreasing? Let's come to the decreasing function. Decreasing function. This one is very different from other graphs, but it's so simple, guys. Very simple. So this graph, it decreases when the value of a, it is bigger than 0 and smaller than 1. This is an interval, guys. This basically means the value of a, it is between 0 and 1. This is the definition of this interval. It means the value of a, it is between 0 and 1, or the value of a is bigger than 0, smaller than 1. That's the definition of this interval. What does it mean really? Traditionally, what does this interval means? That says the value of a is bigger than 0, smaller than 1. It means the values between 0 and 1 are usually fractions. 1 over 3, 0.5, 1 over 2, 3 over 4, 0.75. Those are fractions, meaning let me just write them. 1 over 2, 1 over 3, 3 over 4, or such values that have got fractions. That all values that are between 0 and 1 are decreasing. Meaning our graph, those values determine or will tell you our graph is decreasing. When you see a fraction that is more than 1, bigger than 0 also, it means our graph is decreasing. How will the shape of the graph will look like? This is how the shape of a graph will look like when you draw it, guys. It means it comes from an increasing function to decreasing function, decreasing function to increasing function. Simple, guys. This is how a graph will look like. Let me just yeah, perhaps draw the graph. Maybe let me just do this. Okay. Perhaps, guys, let me just say you've got this. Yes, guys. I hope guys you see it. I hope guys you see it. Even if, let me just say we've got y equal 1 over 2 to power x. Then if you want the intercept, you want to let x be 0 to find y equals to 1 over 2 to power 0. Then 1 over 2 power 0 is equals to 1. The coordinates of x-intercept are going to be 0 and 1. 0 and 1. 0 and 1, guys. So before you can deal with exponential functions or inverse of exponential functions, you ought to understand the basics of exponents. Those exponents you did in grade 8, grade 9, grade 10, grade 11, even now, you're still doing those exponents in grade 12. You ought to understand, where do I come from in terms of exponents? Where I understand the exponents. If you don't understand them, just go back to the basics of exponents, guys. Yes. Now, let's come to let me just say the general equation of exponential graphs. The general is y equal, let me just say perhaps b is any number. Basically b is a constant, it's our constant, any number, b times a to power x plus p plus q. Simple, guys. It is so simple. You don't need to shake. It's so simple. The value of b, it is any number. It is basically any number, constant. The value of e it still plays the role of determining the shape of the graph. It is either increasing or decreasing. Then the value of p, if this is x, the value of p is not asymptote, but it determines the shifting of the graph. Basically, the value of a, it talks about shape, whereby it will tell you, no, this graph it increases or decreases. Then the value of p, it describes the shifting. Basically, when the value of p it is bigger than 0, or when the value of p is positive, that means shifting is going to happen. Shifting is going to take place to the right. I will just explain this at a later stage. Then if the value of p is bigger than, it is smaller than 0, it is negative, then shifting to the left. I hope guys you understand. I hope guys you clearly understand what we are talking about here. Yes. Then let's come to q. Q, in this case, it is our asymptote. The exponential graph has got one asymptote, which is the value of q. Always, for this function, for the zero function, for the sake of this function, the asymptote for this function, y equal b times a to power x plus p plus q, y is equals to q. This is our asymptote. When you say determine the equation of the asymptote of this function, you just say y equals to q. You are done. You are done. I hope guys you understand. Then if also q, it talks about shifting, vertical shifting. Yes, this one is horizontal shifting, vertical shifting, but the value of q has got also an asymptote, shifting again. This shifting, when the value of q it is bigger than 0, obviously upwards, shifting upwards. Then when the value of q it is smaller than 0, when it is negative, obviously downwards. You want to experience, or you're going to deal with such questions when you are moving to the deeper context of this graph, yes, of this function perhaps. I hope guys you understand. So let me just make an example. Before that logarithmic, the definition of exponential function, or the traditional meaning of exponential, or the inverse of exponential function, is just the use of the logarithmic function. Meaning we're basically changing from this exponential form to logarithmic function. Logarithmic function, simple. So you've got y equal 1 over 3 x. So how will you change this to logarithmic? How do you define the inverse? How do you determine the inverse? Perhaps you did the inverse, but first thing first, you swap x and y values. Where you see x, you put in y. Where you see y, you put in x. Simple. Ne? So let's just do that. X is equals to 1 over 3 y. Ne? Then I've swapped x where I see y, I put in x. Where I see x, I put in y. Simple. Then we apply the logarithmic where you have this point. Log of base 1 over 3 number equals to our exponent. Yeah. Basically 1 over 3, it is our base. When you derive it, or when you remove, or when you bring it back to the exponential form, then our y, it is our exponent. Then our x is going to be our subject of the formula. Subject of the formula. Then guys, you are done with logarithmic. Just say, okay, the log of base 1 over 3 subject x equal our exponent y. In this case, then you are done with logarithmic. So this is the inverse of this function. This is the inverse basically. And how do we write inverse? Inverse, you see it by f or g or whatever. But since we are using f here, so you have negative 1x. This is not a derivative, guys, in calculus. The derivative in calculus is f prime x. This is the derivative. This is an inverse, not a derivative. Derivative, you see it by this prime. This is our inverse, f to power negative 1 at x. Then, or prime of, or f to power negative 1 at x. Then you are done. That is your derivative. Ne? I mean, that is your inverse, basically. So guys, you know how do we test this function is this inverse is indeed a function. So we use number one, we use vertical line test. Vertical line test to prove indeed this function is this equation or this exponential graph is a function indeed. So we use the vertical line test to prove is a function. We're gonna deal with that when we arrive to the functions of a parabola also. Then if indeed there's a function, then number two, if indeed it's a function, then we're gonna use horizontal test, where there's 1-to-1 method where this graph touch at one point, and when this graph touches at one point, it means it comes from an inverse, or this inverse is a function. When this inverse touches at one point, or 1-to-1, perhaps we have one x value, x coordinate, and y coordinate. That means if when you draw a graph and you see that graph has got only 1 point, or has got 1-to-1, or this graph touch at 1 point, 1-to-1, meaning we have one x value and one y coordinate. That means this inverse is a function. Then many-to-one, obviously, many-to-one, obviously, it just it touch 2 or more points, and that inverse, it is just a reflection. It reflects in J. It does not mean it has changed, or yes, it is in another form. It just reflected. If the graph was shaping or it was facing upwards, then the inverse of that graph will be sideways. Yes, not downward. If it goes downwards, if it comes a reflection, that means it is no longer a function. It's no longer a function, that graph. Yes. Then I hope you understand. So this one does not have restrictions, just like a parabola. We'll just go to parabola after this one. Explain more into deeper context the concept of the functions or not, and so on, the inverse basically. Yes, let me just draw the graph of f at x equals to 1 over 3x and draw the inverse of that function. F at x is equals to 1 over 3 to power x. Then what is the inverse of this function? I mean, let's draw the graph of this function before you can determine the inverse of this function. Yes, the graph of this function is so simple. Whatever x-intercept, let y be 0, 0 equal to 1 over 3 to power x. Then you want the base to be same. So if there's 0 on this side, obviously no solution. In this case only, no solution. Just know the basics of exponents. Then for y-intercept, let x be 0, y equals to 1 over 3 to power 0. Obviously, number to power 0 is 1. Then you are done, guys. Coordinates of this point are 0 and 1. Then let's just draw the graph of this function. Graph of this function. Guys, we said that, remember, we said that when the value of a it's a fraction, that means our graph is decreasing. Now the value of a is a fraction right now. What will you do? Or how will the graph look like? Because this function or this graph it's decreasing. This graph is decreasing. That means 1 over 3 it is bigger than 0, smaller than 1. This graph is decreasing. Then you need to know how will my graph look like. How will my graph look like? Yes guys, so you know the value of 8 is bigger than 0, smaller than 1. That means our graph is decreasing. So let's just plot this point. Here's our point, and this 1 over 3 to power x. There's a value of q that is invisible. There's plus 0 here. The value of q, when there's nothing, there's plus 0. But when you multiply this, multiplied by 1, you don't change the nature of this, the nature of this equation. So when there's nothing, there's plus 0 in this case. So the value of q is 0. That means our graph won't touch this x-axis line. And also, this thing has intercept has proved that our graph won't touch the x-intercept or the x-axis line because there's no solution at this point. Because where there's y equal to 0, which is on this line, that means there's no solution for this graph at this line. Let me just draw the graph of this function. Yeah, guys, y is equals to 0 and this point is 0 and 1. Then you are done with this graph. Domain and range. Or before domain and range, let me just do the domain and range first. Domain and range. Domain and range. Domain are all x values that are real. Simple. So that those values are from negative infinity to positive infinity, and you are done. Range are all y values that are real, such that, remember, our range are all y values that are real. That means where y is equal to 0, those values are not real. Where y it is smaller than 0, meaning from 0, negative 1, negative 2, negative 10, negative 100, negative 1000, up until negative infinity, those values are not real in that case. Our values start to be real when they're above 0, meaning when the values are bigger than 0. That means y is bigger than 0, or those values are between 0 and positive infinity. 0 and positive infinity. Then you are still correct if you say this, guys. So those values are bigger than 0, meaning y should be bigger than 0. Then you have to prove indeed our graph it is increasing. I mean, our graph it is bigger than 0. I mean, our range is bigger than 0. Yeah. Here, from this 0 up to the downward part, those y values do not exist. That's the case, guys. The inverse of this function. Let's just simplify the inverse. The inverse, we have what? We've got 1 y equal to 1 over 3 to power x. Then obviously we swap x and y for the inverse here. Then logarithmic log base 1 over 3 number equal to y. This is the logarithmic. This is the inverse of exponential graph, which is in the form of a logarithmic form. Yeah? So guys, logarithmic is so simple. There's no change of shape or anything. It's still exponential, just that it has changed the direction, basically. The change, the inverse, the opposite, basically, or the reflection, basically. That is the meaning of a inverse, guys. Now, guys, when you draw the graph of inverse, you can use the calculator. There's log on your calculator. Next time I'll just show you, when I've got time, maybe during the week, I'll just show you how do you draw the graph of this function with the use of calculator. But you can just use the basic logic, the basic logic of inverses. The inverse means we go to the swapping. We swap, and here we have swapped to x and y. Let's swap x and y here again. Let's swap it, guys. And here our x, it is 0, and our y, it is 1. Then basically when you swap x and y, you're gonna have 1 and 0. Where do you find 1 and 0? Here. These are 1 and 0. Then remember, we said that our y is equal to 0. Now again, when I say therefore our x is going to be equal to 0. On which line between x-axis and y-axis will you find x where it is equal to 0? On our y-axis. That means our graph won't touch the y-axis. It will pass next to that line of y-axis. The opposite, or the swapping, we just swap the coordinates. You are done, guys. Let me just draw the graph of this function before. Let me just draw the graph of this function. Yeah, bona, guys. This is how the inverse of this graph will look like. And you've got the reflection, meaning you've got an equation of axis of symmetry for this function, meaning where the graph cuts into two pieces. Where the graph cuts the two graphs into two pieces. It is a scattered line which cuts the graph into two pieces. Simple. This is how it looks like. And it should pass the origin. It should pass the origin. Nebona, guys. This is how our inverse will look like. Then it's going to be y equal to x. Guys, you are done. Guys, you are done drawing. And the coordinates of this point are going to be 1 and 0. Then you are done, guys. You can use your calculator to find the coordinates for the shape of this function. But you are done. In this case, you are done, guys. So, guys, let me just do some few examples to prove my theory, or to prove what I'm talking about. So, I'm gonna have 2 examples. The domain, guys, obviously is going to be still the same. The domain. So let me just determine the domain. Domain and range. Domain for the inverse only, and the range of the inverse only. Over the domain is all x values that are real, such data. So guys, for our domain, it don't be the same because we have swapped here. Basically, even on this one, are you aware already? This graph, it does not come to this side, like this side of the x of the negative infinity. That means our graph won't touch, or our graph ends where x is bigger than 0. Because there's no graph, there's no inverse on this side of the x-axis, on this negative infinity of the x-axis. Our graph only ends, it comes from this side up until the positive infinity of the x-axis. That means our x should be do what? What should x do? Our x should be bigger than 0. The inverse. Y should be bigger than 0. The inverse, x should be bigger than 0. Same applies to the range. Range is all y values that are real. All y values that are real. When you check this graph, then to the from here, we have got this graph comes from positive infinity, and this graph, it comes from positive infinity, negative up until negative infinity. Basically, this graph is going to look like this, guys. Basically, but it won't be constant. Just like I've drawn it, it won't be constant, but it will look like this. Meaning our graph will extend. Our graph will extend like this up until negative infinity. That means from positive infinity to negative infinity. The swapping, guys. The swapping. Simple, guys. Can you see good how simple is it? Let me just make an example. One example or two, so that you can see good how does this graph behaves. Yes. So guys, here are two examples that you're gonna deal with for today. Yes, guys. So let's start with this one. Y is equals to 2 to the power x plus 1 plus 1. We draw the graph, the intercept, asymptote, and the dominant range. Simple. Yes. Y intercept, let x be 0, then 0 is equals to 2 to power x plus 1 plus 1. Okay, then we're going to transpose this negative 1 to the side, because 0 minus 1 is negative 1. 2 to power x plus 1. Then because we have a sign here that is different from this one, then there's no solution without wasting any time. You can just solve it further. You'll see there's no solution for this one, but sometimes there could be a solution. There could be a solution, but we will arrive to that part. So the x-intercept, we let y be 0. Let y be 0. 0 is equal. Oh guys, I made a mistake here. Basically, when we want y-intercept, we let x be 0. Meaning, let me just fix this problem here. When you want x-intercept, we let y be 0. Then here, when you want y-intercept, we let x be 0. So guys, so you're gonna have y equal 2 to the power 0 plus 1 plus 1 equal to 2 to the power 0 plus 1 is 0 plus 1 is 1. Then 2 to the power 1 is 2 plus 1 is 3. Then coordinates of this point are 0 and 3. Then you can draw the graph of this function by the use of those coordinates in J with your intercept. With your intercept and our asymptote. Simple, Very simple, guys. Very simple. These problems are so simple. What is our asymptote, guys? What is our asymptote of this function? It is our 1. That means the value of y is equals to 1, or the asymptote of this function is 1. Y equals to 1. Then you are done with your asymptote. How will our graph look like? The shape of the graph. Remember, guys, we said that if the value of a is bigger than 0, our graph will look like this here. Our graph will look like this. Remember, if the value of 8 is bigger than 0, smaller than 1, yes, our graph will look like this here. This is what we said. So now the value of 8 is bigger than 0. That means our graph, we have a point, remember 0 and 3 here. That means our graph will look like this here. Our graph will be like this, or will look like this. The shape of the graph will look like this. Then you are done. You got 0 and 3 here. Then you are done, guys, with this graph. Domain and range. Domain and range of this function. Domain, all x values that are real. Domain, obviously, you see this graph. It involves negative infinity numbers and also positive infinity numbers, because this graph it increases, meaning it comes from negative infinity. It comes again negative infinity, positive infinity, because on the side it is also visible on our positive side of the x-axis. That means our graph, it comes from negative infinity to positive infinity. We don't know those values. Even our range is y is the element of random number such that, what is our range? You know what's about y on it is our range. That means we need to check what our axis. Where is our axis? Where our axis is based? Which values are undefined on our axis is 1. We saw what 1 is our y is our asymptote. It means our graph is not found where we have 1, or where the y coordinate is equals to 1 here. Meaning from 1 to this side, our graph is not found from 1 to the negative infinity of the y-axis. But our graph is found only when y is bigger than 1 up until positive infinity. Do you see, guys, how do you determine the range and domain? Therefore, y should be bigger than 1. Or y, it comes from 1 to positive infinity. Sorry guys, that means we don't include the square brackets because 1 is not involved, or it is not included in this case. Hence we say if you include the square bracket, you're gonna get it wrong. If you include the equal sign here, you're gonna get it wrong, because 1, it is infinite, or it is invalid where you have y is equals to 1 because of the asymptote. Hence we say y it is invalid where it is equals to 1 because of the asymptote. And here we cannot put in the square bracket because 1 is not involved, or 1 is invalid because this is our asymptote. Even here you can just say bigger than or equal to. No, you're gonna get it wrong. Just say y equals to 1, or 1 is between 1, y is between 1 and positive infinity, or you can say 1 is bigger than 1, smaller than positive infinity. Then you're still correct in these two ways. Let's come back here guys. Simple. I hope you understand what I'm talking about here guys. Yes, I hope you understand what I'm talking about. Yes, here simple. Let's draw the graph. In x-intercept, you let y be 0. Simple. 0 is equals to 2 1 over 2 x plus 1 minus 4. Guys, in order for you to draw the graph of this function, know the basics of exponents, then you're gonna get it right. We transpose this negative 4 to this side, is going to be equal to 4 equals to 2 1 over 2 x minus 1. Again, then we are multiplying a constant here, the value of b. We divide by 2, this 2 again. Then you're gonna be left with 2. 4 divided by 2 is 2. You're gonna be left with 1 over 2 x minus 1. Then now guys, we want 2 and 1 over 2 to be the same. You know, the inverse. Let me just check. The inverse of 1 over 2 is equals to 2 to the power negative 1. 2 to the power negative 1 is the same thing as saying 1 over 2. It's the same, guys. Even if we've got perhaps we've got 2 to the power negative 2 here. Yeah, I hear what's another 1 here, invisible 1. This one is going to be our numerator. 1 over is going to change the sign to 2 squared. 2 squared is equal to 1 over 4. That's how we determine, or that's how we solve a negative exponent. Go back to your exponent rules. You're gonna get it wrong if you don't know such basics. You're gonna get it wrong. Yes. So this is how we do it, guys. Let's come back here. So we're gonna have x minus 1 equals to 2 equals to, guys, you know good the rules of exponents. Whatever the exponent that is inside the bracket should multiply whatever exponent that is outside the bracket. The negative 1 is going to multiply x. Negative 1 is going to multiply negative 1 also. Simple. So we're going to have 2 to power negative 1 times x is negative x. Negative 1 times 1, negative 1 times negative 1 is positive 1. Then it's 2 to power 1. Our bases are the same. You equate the exponents. 1 equals to negative x plus 1. We transpose this one to the side, is going to be 1 minus 1 is 0. Then negative x is equals to, then whatever a negative 1 here, we divide both sides by negative 1, x is equals to 0. 0 divided by negative 1 is 0. Simple. The coordinates of x-intercept, 0 and 0. Origin. Can you see, guys? Let me just cut so that you can see where we are. Wow. So I'm just saving the space. Guys. So we are working on this side only for this function. Then x-intercept, y-intercept also. Y-intercept, we let x be equal to 0. We let x equal to 0, then y is equals to 2 multiplied by 1 over 2, 0 plus 1 minus 4. Simple. Let me just simplify it for you guys. 2, 1 over 2, 0 plus 1 is 1 minus 4. Then guys, here it's so simple. Whatever is 2 over 1 again, 2 over 1 here, 2 over 1. So guys, here whatever 2 multiplied by 1 over 2. Numerator, denominator. Simple. You just multiply the numerator by the numerator, denominator by the denominator. 2 times 1 is 2. 1 times 2 is 2, minus 4. Then 2 over 2 is 1. 1 minus 4 is negative 3. Then you are done. Coordinates of the y-intercept are 0 and negative 3. Then with these coordinates, together with your asymptote, you can just draw the graph of this function. Simple, guys. Simple. Let us draw the graph of this function. The graph of this function. Now, before you can draw the graph, just need to point out your asymptote, negative 4. Where is our negative 4? On this side, negative 4. negative 4. That means your y is equals to minus 4. Then you are done, guys. Let's plot those points. 0 and 0, remember, you got 0 and 0. Here's our origin. 0 and negative 3. 0 and negative 3. Yeah, wanna guys. Guys, I'm surprised to go to why do we have these points are like this. I'm surprised. What's happening? I don't know what's happening. But let me just go back and check. Maybe perhaps I did a problem, but here I didn't know. I didn't have a problem. There's no problem here. I'm not sure. Let's just go back here. Let me just check. Where did I go wrong? 0 equal to multiply 1 over 2. X plus 1 minus 4. It's okay. Then I transpose this 4 to this side. Is going to be 4 equals to 2 times 1 over 2 times x minus 1. Problem comes here. I said x minus 1. I was in a hurry to multiply it with this negative 1. Hence I said maybe perhaps my head was forward. My brain was so forward, guys. So I made a mistake here. I just changed automatically. By default I changed from positive to negative. I don't know why, because there's no sign that is gonna change this negative. I mean, from this positive to negative. So guys, sorry for that. Sorry, it's positive here. Second mistake, it's positive there. Sorry guys, positive. That means when I multiply this negative by positive, it's gonna give me positive here. Then you're gonna have positive here. Then 1 plus 1. Negative here. When you put it on the other side, it's going to be 1 plus 1. Then it's equals to 2, guys. Then therefore the coordinates of this point, here we're going to have negative 1 divided by negative 1 on both sides. Meaning you're going to have 2 divided by negative 1 here. Then you're going to have a negative. You're going to be left with negative 2. Therefore the new coordinates of this point are negative 2 and 0. So guys, sorry for the mistake. At least I've realized I made a mistake. Just imagine I was just gonna leave you guys like this, then you're gonna get it wrong. So the new coordinates are negative 2 and 0. So guys, we got 0 and negative 3 and negative 2 and 0. These ones are invalid. Origin is invalid. Our origin is so invalid. Scratch it, guys. Sorry for the inconvenience. Now let's draw the graph. Remember, let's come back here. The value of a, it is 1 over 2. It is our half. What did we say about the 1 over 2 halves thing? Let's go back to previous example. Yes. Let's go back to the previous example. Let's come back here, guys. Yeah. We said go to when you have a fraction. That means when you have a fraction, that means the graph will be shaped like this. When you have a fraction. So basically, when the value of a it is bigger than 0, yes, bigger than 0, smaller than 1. I mean, when the value of a is between 0 and 1, that means our graph will shape like this. That means this graph is going to look like this. It's going to be shaped like this. Guys, this is how our graph will look like. Then the coordinates negative 3 and 0, then 0 and negative 3. Negative 2, guys. Sorry, negative 2 here. Actually, I don't know what's happening with me today, but at least, guys, you've got it okay. This is how our graph will look like. Then, sorry for the space, but for here, we're gonna just determine the domain and the range of this function. Domain are all x values that are real, such that domain, obviously, because this graph is visible on the x-axis negative infinity. Also, this graph is invisible on the positive infinity function. Yes, you're correct, guys. Those values are from negative infinity to positive infinity. Then our range, is so simple. Y is the element of real numbers, such that let's check our range. So our range becomes undefined when y is bigger than negative 4, because our range is visible here, our graph is visible in terms of our y values from negative 4, negative 3 is invisible, negative 2, negative 1, 0, 1, 2, 3, 4, 5 to positive infinity. All those values are visible. But when those values are less than -4, meaning both -5, -6, -7 are not there, meaning are not involved in this graph, are not part of this graph. Those values are not part of this graph. That means y should be bigger than -4, meaning y should be bigger than, meaning if I say y should be bigger than -4, it means those values should be -3, -2, -4, and 0, 1, 2, 3 up until infinity. That's how you determine the range of exponential functions. So guys, I guess I'm done for today. Let's meet up when you do some previous question papers in the following week. So I don't want to go deeper into context, many perhaps examples for this function, but this basics will help you to simplify other questions. So along the week, I'll just come back to the functions and explain more better and better and better and better. We're gonna explain more questions that are examinable. You know me, guys. I'm best at giving you examples that you are sometimes scared of, that are so simple. Also, those examples that you see that seem to be so scary are so simple. So guys, for today, for now, I'm done. Let's meet up when we do question papers starting from on Monday, the 6th. Yeah, I'm gonna do question papers up until Thursday in the evening. So hopefully you're gonna enjoy the rest of the week. Thank you.